As we look at 8.4, we have double distributive again, but there's some special types. Now, here's the thing. We're going to do a quick little review piece, and then we're going to get into the special types. But I don't want you to think of them as something more. It's just if you notice the patterns, great. However, you can always do FOIL. You can always do the first, outer, inner, last piece. You can do the double distributive, however you want to think about it, or even the box. In the end, there are just some patterns that will help you in the end if you start noticing them. So this first part is just a review. So go ahead and multiply and then use the FOIL box or box method on 3 and 4, and then we'll get into the next part. So try those and then come back to me. So this first one's negative 4x squared minus 12x. The next one, we're going to multiply each piece. This is a trinomial, so keep in mind there's 3 terms here. So 3 times 7, or 5 times 7 is 35. M to the 2 and 5 is 7. N to the 3 and 4 is 7. Negative and a positive, so 5 times negative 11 is negative 55. And this is to the 1 and this is 2, so it's 3. N to the 3 and n to the first is n to the 4th. And then times 9, so 5 times 9 is positive 45. And then just bring it on over, m to the second, n to the third. The next set, we're going to do a double distributive or the box, whichever way you like. If you like the box, remember you can always do x plus 2 and x minus 10, giving me x squared, negative 10x, positive 2x, and negative 20. So this would be x squared, negative 8x minus 20. This next piece, we're going to do the double distributive. I'm going to do it this direction. So I'm going to have 3x squared minus 24x inside negative 4x plus 32. Combine like terms, 3x squared minus 28x plus 32. Now we get to special types. Okay, so perfect square trinomial means I'm going to have the exact same thing in both sets of parentheses. So binomial and a binomial, but they're the exact same. So basically you do the same thing, but when you multiply them out, I get x times x is x squared. X times 3 is positive 3x here. 3 times x is plus 3x. And 3 times 3 is positive 9. Add these together, I'm going to get x squared plus 6x plus 9. You should notice that the first term is a perfect square and the last term is a perfect square. And the middle term is basically the first and last multiplied times 2. However, you can always do FOIL or the box and you'll get the right answer every time. So that's the perfect square rule. So try these on your own. So pause me and try them. All right. So we should have x times x is x squared. Even it's plus 7x plus 7x plus 49. So we get x squared plus 14x plus 49. Again, perfect square, perfect square. First set multiplied by each other here, we end up with the 14x. So 7x and 7x. This is the same thing. I'm going to have an x squared minus 6x plus 36. So x squared minus 12x plus 36. What's happening right now is we're stepping forward. We're basically learning a little dance. We're going forward each time, multiplying things out. What's going to happen in about a couple days is I'm going to start making you break these apart. So when we start, I tell you, I want you to notice something. I want you to notice that my last term and my first term are perfect squares. And then we can break them out and see how we can get that negative 12 in between. So we would know that 36 is a perfect and x squared is a perfect. So 6 times 6 gave me 36. And we know that 6 plus 6 is 12, but they're both negatives. Number 3, same idea here. 5x times 5x is 25x squared. 5 times 4 is plus 20x. 4 times 5x is plus 20x. And 4 times 4 is positive 16. Combine like terms. 25x squared plus 40x plus 16. Okay, then we have this difference of squares. There's a little bit of a rule here. When multiplying binomial by a binomial with the same first term and opposite second term, you're going to multiply the first term, multiply the second terms. The middle terms will end up canceling out. So, difference of two squares have different signs. Same signs, same signs. So here, these have different signs. So it's going to be a difference of two squares. But you still can do it by the box or by FOIL or by double distributive, however you think about it. So x times x is x squared. X times negative 10 would be negative 10x. Positive 10x, and 10 times negative 10 is negative 100. Here's what I mean. Negative 10x plus 10x cancel each other out. I'm left with x squared minus 100. So a difference of two squares ends up with a binomial, two terms, with a minus sign in between. So a perfect and a perfect with a minus in between. So it's a difference minus sign of two perfect squares. That's why it's called the difference of two squares. This one, however, is a perfect square because they're the exact same. So we know it's going to be a trinomial. So it's going to be x times x is x squared. X times negative 9 is negative 9x. Negative 9 times x is negative 9x. Negative 9 times negative 9 is positive 81. So now I get x squared minus 18x plus 81. So the first thing you need to do is decide, is it a perfect square or a difference of squares? So this one is perfect because it's the same and same. So it's going to end up with a trinomial. Here I've got difference, so it should end up with a binomial. So m times m is m squared. M times 12 is 12m. 12 times m is 12m. And 12 times 12 is 144. Combine like terms. M squared plus 24m plus 144. And this one's, they're different, so they should cancel out. So let's double check. X squared minus 2x plus 2x minus 4. So I end up with x squared, these canceled, minus 4. It's a difference of two squares. Looking at the top portion of this, we just have 4 more to do. This one is written a little bit different, but it means I want that quantity 2 times. So that really means x minus 8 times x minus 8. And then you can do FOIL. So x times x is x squared, negative 8x, negative 8x, and plus 64. So x squared minus 16x plus 64. You can pause me at any time, try them on your own, and then come back. So 5x times 5x is 25x squared. 5x times 7y is positive 35xy. Negative 7y times 5x. You always go in alphabetical order, so it is going to be negative 35xy. And negative 7 times 7 is negative 49y squared. These two end up combining and they cancel each other out. So I'm left with 25x squared minus 49y squared. It is a difference of two squares. This is a perfect square. Number 7, same with the same signs. So it's going to be a perfect square. So I'm going to say 3x times 3x is 9x squared. 3x times 4y is plus 12xy. 4y times 3x is still 12xy, and 4y times 4y is positive 16y squared. Combine like terms, 9x squared plus 24xy plus 16y squared. And number 8, last one. 2a squared times 2a squared gives me 4a to the fourths. 2a squared times 3b gives me positive 6a squared b. 3b times 2a squared gives me 6a squared b. And 3b times 3b is positive 9b squared. Combine that middle term, so I'm going to end up with 4a to the fourth plus 12a squared b plus 9b squared. I tried to show you all of my work step by step, so if it takes you a couple times to rewind and try again, please do, because checkpoint 8 and checkpoint 9, you should be able to do those at this point. So you finished up the notes here for 8.5, but you need to work on checkpoint 8 and 9 as well.